Okay, so first question of the practice basic skills test, and we have root 8 minus 3 root 2 plus root 50. And what we need to do here is with the 8 and the 50 we need to be looking for square numbers that go into 8 and square numbers that go into 50. So a square number that goes into 8 is 4, so we can write 8 as 4 times 2, and a square number that goes into 50 is 25, so we can write 50 as 25 times 2. Then using the rules of thirds we can split up a multiplication inside a single square root and split it into two separate square roots multiplied together, so root 4 times by root 2. And similarly over here, root 25 times by root 2. Finally, to tidy up the root 4 is clearly 2. And root 25 is 5. Okay, so the last line of working out then is to simply collect these together. We've got 2 lots of root 2 minus 3 lots of root 2 plus 5 lots of root 2. So altogether that makes 4 lots of root 2. Question 1b, we have root 3 plus 4 all squared. So the safest thing to do when you've got a bracket squared is to write the bracket out twice, and this helps us avoid missing the middle term when we multiply out the brackets. Okay, so write the bracket out twice, then expand as normal, so root 3 times root 3 is 3, root 3 times 4 is 4 root 3, this 4 times root 3 here is 4 root 3 again, and 4 times 4, 16. Simply collect like terms together. We've got a 3 and a 16, so that's 19, and we have 4 root 3 and another 4 root 3, so that is 8 root 3. Question 1c, we have 4 over 5 minus root 3, and we need to get that into the form a plus b root c. Notice the form that we're aiming to get it into has the root c not in the denominator. That will just be effectively in the numerator. So the problem we have currently is that root 3 is in the denominator, and we need to effectively move that away from the denominator and help it appear in the numerator. Now the way to do that with this style, where we've got an integer minus the third, is to multiply by this almost the same expression, but that was a minus. We're going to make it a plus here, and that's going to help effectively cancel out the minus, cancel out the root 3 in the denominator. But if we multiply the denominator by 5 root 3, we also need to multiply the numerator by 5 root 3 to help keep the value of the fraction the same as it was to start with. Effectively what we're doing here is multiplying by 1, but the 1 is expressed as 5 plus root 3 over 5 plus root 3, and that's just going to help us change the form of the fraction, but it's not going to change the value of the fraction. Okay, let's get on to doing that multiplication now then. So on the in the numerator, the easiest way to express that, which may help cancelling later, is to just keep it factorised. We've got 4 times by 5 plus root 3. So keep that factorised at the moment, because that might help us with cancelling later. In the denominator we have 5 times by 5 is 25. 5 times by plus root 3 is 5 root 3. Minus root 3 times 5 is minus 5 root 3. And minus root 3 times by plus root 3 is minus 3. Now, I hope you can see here that we, in the denominator now, we have a positive 5 root 3 and a negative 5 root 3, and they cancel out, leave in the denominator 25 minus 3, which is 22. So our denominator has now just changed to a simple integer, and that helped us achieve something of what we wanted to do. The root 3 is now only appearing in the numerator. Now I said about keeping the numerator factorised, and this is where it's going to be useful. We have a 4 as a factor of the numerator, and we have 22 in the denominator. Now a common factor of 4 and 22 is 2, so we can divide top and bottom by 2. The 4 then cancels down to 2 there, and the 22 cancels down to 11 there, leaving us overall then 2 bracket 5 plus root 3 all over 11. Okay, no more cancellation can happen because 2 and 11 don't have any common factors, and certainly 5 plus root 3 and 11 certainly don't have any common factors. Now the only final thing to do is to think about getting it into this form a plus b root c, where a and b are rational numbers, that is to say fractions. It's not quite in that format yet. We have everything over 11, so what we need to do is to start to separate it out into a fraction plus a fraction times root 3, and to help us with that, then maybe at this stage we can multiply out the numerator. So we have 10 plus 2 root 3 all over 11, and now we can then split it into two separate fractions. We've got 10 over 11 plus 2 over 11 root 3. And we have it then in the format expected in the question. Question 1D of the practice test. We have 1 minus root 2 over 2 plus root 2. Again, just like part C, the key aim is to get a whole number, an integer, in the denominator. So this root 2 here is causing us a problem. But again, just like in part C, the trick is to multiply the denominator by a similar structure of 2 and then a root 2, but instead of the plus, we flip the sign and make it a minus, and that's going to help us cancel out the root 2's in the denominator when we expand. However, if we multiply the denominator by 2 minus root 2, we need to multiply the numerator by 2 minus root 2 in order to keep the value the same, because 2 minus root 2 over 2 minus root 2 is just the same as 1, and so the value of the original fraction has remained. Okay, let's get on to expanding now, or multiplying out, shall I say. So on the numerator we've got 1 minus root 2 times by 2 minus root 2, and remember that there are effectively invisible brackets around each of these expressions, and similarly in the denominator there. So 1 times a 1 is 2, 1 times a negative root 2 is negative root 2, negative root 2 times by 2 is minus 2 root 2, and negative root 2 times by negative root 2 is positive 2. Similarly in the denominator then, 2 times 2 is 4, 2 times minus root 2 is minus 2 root 2, root 2 times by 2 is positive 2 root 2, and positive root 2 times by negative root 2 is a negative 2. Okay, let's simplify both the numerator and the denominator at this stage. We have 2 plus a 2, which is 4. We have minus root 2 times by minus root 2 minus another 2 root 2, so minus 1 lot of root 2 minus 2 lots of root 2 is overall minus 3 lots of root 2. In the denominator then we have 4 minus 2, which is 2, and notice that we get this nice cancellation, minus 2 root 2 plus 2 root 2 cancel each other out, and hence we get the nice whole number that we wanted in the denominator. Okay, at that stage we should be now looking to separate out into a number, or a rational number or fraction, plus another fraction times by root c, which in this case is going to be our root 2. So let's split this combined fraction into two separate ones. We've got 4 over 2 minus 3 root 2 over 2. Now 4 over 2 is clearly 2. 3 root 2 over 2 can then be written as 3 over 2 root 2 to get it in more precisely the form requested